So, characteristics of sinusoidal functions. Sinusoidal functions are graphs that look like sine waves. And as we've seen, the cosine wave looks just like a sine wave that's been shifted over. So sine x and cos x are both sinusoidal functions. One of the characteristics of a sinusoidal function is that they are periodic. In other words, they repeat themselves. And if you notice on our graphs, how often does a sine wave repeat itself? So to have one crest and one trough on a sine wave takes how far in the x-axis? It's more than pi, 2 pi. The period of a sine wave and a cosine wave are both 2 pi. So it's going to repeat every 2 pi. Okay? Now we've talked extensively, maybe not extensively, but we talked a lot about domain. What's the domain for both of these functions? Andrew, what's the domain for both of these functions? All real numbers. Okay? And what about the range for both of these functions? What's the range, Maddie? Very good. Okay, between -1 and 1. Now the y-intercepts and the x-intercepts are different for the two functions. So the y-intercept is, the y-intercept for y equals sine x. Where does y equal sine x cross the y-axis? Hannah? Where does y equals sine x cross the y-axis? Well, it's 1 or 0. Those are your two choices. So sine is one of them and cosine is the other one. Look at your graphs that you did from yesterday. Do it again. Y equals 0. And cosine x crosses the y-axis at y equals 1. So we need to remember those because that's key in graphing these functions, is where is the y-intercept. Okay? The x-intercepts are different for both of them as well. And we just wrote down the general equation for the x-intercepts. Who can remember the general equation for the x-intercepts for sine x? N pi, remember? And for cos x, then what is it, Demetria?
It's pi over 2 plus 10.
Correct. Or 2n plus 1 times pi over 2. And in both of these cases, n has to be an integer. Okay, so it's odd multiples of pi over 2, or take the first 0 and add multiples of pi to it, because it's repeating the zeros repeat every pi. Okay? So the two other aspects that I wanted to talk about today is the fact that y equals cos x is the same shape as sine x, only it's been shifted. And how did we shift sine x to get cos x? Sine x has to get shifted to the left, pi by 2. Okay? Here we graphed it, we did cos x, right? Cos x can get shifted right pi by 2, or sine x can get shifted left pi by 2, so that they match up with each other. Okay? And the last thing is what we call the amplitude. The amplitude of the graph for a basic sine function or a basic cosine function, we're talking about waves. Does anyone know how we define the wave, the amplitude of a wave? Who wants to try? All right, Emily?
Distance between crest and trough.
That's not bad. That's not bad, but that would be double the amplitude. So it's not the distance between the crest and the trough. Curtis? What were you going to say?
Would it be the distance between the midpoint
Yeah, exactly. So the distance to the crest from the midpoint or to the trough from the midpoint. Distance from midpoint to max or min. Okay? And on our graph, where that shows up is that if we have y equals, let's say, 4 sine x, then the amplitude is 4. Because that's where the maximum value is going to be. That's now a vertical expansion by 4, so now the maximum goes to 4, and the amplitude would be 4. If we have y equals just regular sine x, what would the amplitude be for that? 1, because that's the maximum value, right? It goes up to positive 1 and down to negative 1, so the amplitude is 1. Notice that amplitude is always positive. So we don't care if we're going up to a crest or down to a trough. It's not a vector that we're measuring, it's a scalar. So we just want to know that the value, we don't care about the direction. We don't care if we're going up or down. Okay? Questions for me?